Hi everybody, Hi everybody. Here's Mr. A again, and I have a question about resolving vectors or resolving forces and finding certain values related to that. The question appeared on the Wyzant website. A student wanted to know, and I am answering. Um, as a recording. Okay, so the question is this. A student applies a force of 150 newtons on a 15 kilogram box by using a rope held at an angle of 35 degrees above the horizontal. The coefficient of friction between the box and the surface is 0.90. There are two parts. A is asking to calculate the vertical and horizontal components of the 150 Newton force, and then part B is asking to calculate the acceleration of the box. Now, part A is fairly straightforward. All it's asking is for the components, and so as long as you know your vectors, that shouldn't be a problem. The second one is a little bit more complex because you have to go through a few steps to figure out all the relevant information. So let's go ahead and look at the solution. As usual, I have the solution here to save time, and I will go through it with you so you can understand what's going on. Okay, so, and I have a little diagram to show that there is the box and the mass is 15 kilogram, which works out to a weight of 147.15 newtons. There is a force of 150 newtons acting, as you can see right here, acting to the at 35 degrees to the horizontal. And then I have drawn these two dotted lines to indicate the vertical component of this force and the horizontal component of the force. The vertical component we're going to call Fy and the horizontal component Fx. All right. So for the first part, like I said, it's pretty straightforward. Fy is the sine 35 of 150, which comes out to 86.04 newtons. And then the horizontal component Fx works out to 150 times cosine of 35, which is 122.87 newtons. So that's part A, and that's, like I said, pretty straightforward. But these values will have to be applied to part B. So let's see what part B is. Oh, let me keep the diagram here. Sorry about that. Okay, so part B is asking for the acceleration. And acceleration is a consequence of net force. You are familiar with the expression F equals ma. So we're going to use that formula, but we have to figure out how much the net force is. Okay, so to find the net force, now we have a horizontal force because the object is going to accelerate along the surface, along the horizontal. So there will be a horizontal force acting to the right, and there is a horizontal force due to friction acting to the left. All right, the horizontal force acting to the right is already calculated as Fx, which is 122.87 newtons. But we still need to figure out what the frictional force will be. To find the frictional force, we use the formula F frictional equals mu times F reaction, where reaction is the force that holds the surfaces together. Now, in this situation, if you notice, there is a weight which is acting vertically downwards, but then there is also a vertically upward component of the 150 Newton force with which the thing is being, or the box is being pulled. So there is a vertical force downwards and a vertical force upwards. And a quick note here that when you are determining the resultant of vectors, it really does not matter so much what the location of that vector is, unless you're dealing with the moment of the forces or the vectors. So irrespective of where physically the force is acting, As long as it's in the vertical direction, we can add and subtract. So you subtract the upward force, which is a smaller quantity and is 86.04 newtons, from the downward force, which is 147.15 newtons, and we come up with a resultant 100 and the resultant force of 61.11 newtons acting downwards. That downward force is holding the box on the surface, and that therefore is the normal reaction. All right. So, or at least that is a magnitude of the normal reaction. So for frictional force, mu is given as 0.9, and the normal reaction is 61.11. Solving that from this equation, we come out to 54.999 newtons. Okay, but that is just the frictional force. Now, to find out acceleration, like I said earlier, you need to have the net force. Net force in the horizontal direction is a difference between the rightward force and the leftward force. Rightward force is 122.87 newtons, and the leftward force, which we just calculated, is 54.999 newtons. So we take those two forces, divide them by m, and plug them into this equation. So in other words, we're going to divide afterwards. We plug this into the equation F equal to ma, according to which A turns out to be F over m. F is the resultant force acting in the horizontal direction, which is 122.87 minus the frictional force 54.999. So we subtract those, divide by 15, and the acceleration works out to 4.52 meters per second squared, which is a huge acceleration. But anyway, that is all there is to it. If anyone has any questions, please let me know. This is Mr. A signing off.